All right, so our lesson notes today are about square roots and cube roots. I talked a little bit about square roots and cube roots yesterday, but for today we're going to actually learn that square roots and cube roots could actually be written as exponents. So it turns out a square root a square root, taking the square root of a number is exactly the same as taking that number and raising it to the power of 1/2. Okay. So taking the square root of a number is exactly the same as raising that number to the power of 1/2. So the example I gave here, the square root of 25, which we of course know is positive or negative 5, that is exactly the same as taking 25 to the power of 1/2. If you were to put 25 to the power of 1/2 in a calculator, you would get positive or negative 5. Okay. And it turns out that if you change the denominator of that fractional exponent, that changes the root. So if I were to make it a power of 1/3, that would be the equivalent of a cube root. So taking the cube root of a number is exactly the same as taking that number and raising it to the power of 1/3. So for example, the cube root of 8, which we know is 2 because 2 times 2 times 2 is 8, is exactly the same as taking 8 to the power of 1/3. And that pattern actually continues. So if we were going to do a fourth root or a fifth root or a sixth root, those powers would be 1/4, 1/5, 1/6, so on and so forth. And that is really all we're learning about today, is using that fact that taking the root, the square root or the cube root of a number is the same as raising that number to the power of 1/2 or 1/3. So let's take a look at the examples here. And these are the similar examples that you'll see on your cool down tonight. So number 1, solve the equation x squared equals 11 and write the solution in two different ways. Write the solution in two different ways using exponents and using roots. So let's look at this one. So x squared equals 11. Okay, we learned way back in our quadratics unit that I can solve this because the exponent here is squared. I can solve it by taking the square root of both sides. Now, why can I do that? I can do that because square root and squared cancel each other out. So if I was going to write this answer, the square root of 11 is not a perfect square. Square root of 11 is a decimal. So I would write this as positive or negative square root of 11. Positive or negative square root of 11. This right here, this is actually the answer to part B. This right here is the answer to part B because this is write the solution using roots. Okay. Now, if I wanted to take that same solution and write that answer using exponents, I would go back to my lesson notes and use the fact that taking the square root of a number is the same as raising that number to the power of 1/2. So the only thing that will change is I will still have my plus and minus. The only difference is instead of writing square root of 11, I will write 11 to the power of 1/2. 11 to the power of 1/2. This is the solution using exponents. So I actually did part B before I did part A. That is all you had to do for number 1. Number 2, we're doing the same thing, except notice the equation is x cubed equals 11. So to solve that equation, instead of taking the square root of both sides, since squaring and square rooting are opposites of each other, I could do the same thing with cubing and cube rooting. So I'm actually going to do the same thing, except I'm going to take the cube root of both sides. Similar to squaring and square rooting, these things are opposites of each other, so they will cancel each other out on the left-hand side. So then the only question is 11 a perfect cube? Is it possible to take a whole number, cube it, and get an answer of 11? And the answer is, of course, no. So I'm going to leave the answer as the cube root of 11. Now, we talked about this yesterday. When we do a cube root, do I need to put the plus and minus in front of it? And the answer is no, I don't. The reason being is if I square a positive or a negative number, the answer will be positive. That's why we put the plus and minus when we do square roots. But when we do cube roots, if I cube a positive, I'll get a positive. But if I cube a negative, take a negative number and cube it, I will get a negative. So I don't need to write the plus or minus. X is simply going to equal the cube root of 11. So once again, this is actually the answer to part B. This is write the solution in two ways. This is the writing the solution using roots. And then to write the answer, to go back to part A, to write the answer using exponents, I'm going to simply do the same thing I did. Simply do the same thing I did for number 1, and I'll just say x equals 11 to the power of 1/3. Okay, taking a number and raising it to the power of 1/3 is the same as cube rooting it. So this right here, this right here is the answer using exponents. Okay, number 3. We write the cube root of 83 using exponents. Now, before we answer that question, I first want to go back and do what we did yesterday. I want to learn about. I want to talk about what is the cube root of 83 between. Okay, and we did that. We did a little bit of this yesterday. Okay, we talked about. Okay, so if I know, for example, that let's see, I know that, for example, that 4 cubed is, let's see, 4 times 4 is 16. 16 times 4 is 64. Okay. And I know that 5 cubed, let's see, 5 times 5 is 25. And 25 times 5 is going to be 125. So 4 cubed is 64. 5 cubed is 125. All right, 83 is obviously between those two numbers. So I know that the cube root of 83 is somewhere between 4 and 5. And it turns out on Desmos, and I did not talk about this yesterday, if you wanted to actually find the exact value of the cube root of 83, okay, if you're on Desmos, and see right down here is the square root button, but if you go to functions and then click on miscellaneous, so again, go to functions and then go to miscellaneous, notice over here, it looks like a square root with an n over it. So if you have any root other than the square root, I'm going to go here, and now I could type in a 3 there to make that the cube root of 83, and notice it tells me it is between 4 and 5. Okay, so I never showed you this yesterday, but that is how you do cube roots on Desmos. Now, going back to answering the question, rewrite the cube root. Whoops. Rewrite the cube root of 83 using exponents. All right, using exponent is simply going to be 83 to the power of 1/3. Again, square root is to the power of a half. Cube root is to the power of 1/3. And that is it for this lesson here.